Hi guys, today I will walk you through our modern AI with Unsloth AI assignment. So we have five different collabs in that. So first one is training a lightweight LLM with Unsloth AI. So first in this we'll start with setting up our Google Colab by installing necessary libraries such as Unsloth, then Hugging Face, transformers, datasets, and tracking tools like weights and biases. This setup ensures our environment has everything for optimal training and compatibility. Then we will start with importing and initializing the environment, and after that we will move on to authentication and dependencies. We will securely authenticate with Hugging Face and weight and biases, so training metrics and models can be stored or deployed with ease. This uses collapse user data for handling tokens securely. Then we will go with version compatibility setup, and then we will start with model and dataset preparation. So in this we will load small LM2 135 million parameters base model and retrieve a small sample from the alpaca dataset tailored for quick experimentation. We pre-process these samples using a specific prompt template to structure the instruction input and response format needed for fine-tuning. After this, we will load the dataset. As I have said, we are using alpaca dataset in here. Then we will move on to model training, configuration, and fine-tuning setup. And then we will monitor the performance of our model. So in this we have 189 steps, 3 epochs, and 500 examples. Then we will move on to training completion and resource summary. And then we'll move on to testing. This is the testing part. And then at last we will publish our model to Hugging Face Hub. So as you can see, I have published it in my Hugging Face profile, and it is saved like this. So that is it for this one. Then we will move on to second one, which is using LoRa parameter efficient, and we'll fine tune using it. First we'll start with installing required libraries: Unsloth dataset, transformers, Hugging Face, weights and biases. Then we will import all the required libraries. Then we'll move on to authentication and token setup of Hugging Face and weights and biases. Then we'll load our base model and tokenizer. We are using same model, which is small LM to 135 million parameters. And then we will add our LoRa adapters in this, and we will prepare and format the dataset. Then we will configure our trainer for fine-tuning and we will start fine-tuning process in here. I have used 189 steps, 3 epochs, and 500 examples here. And then this is the training summary. It took around 2.39 minutes, and peak reserved was 1833 GB GPU memory. And then we will go to inference and model evaluation, and at last we will upload the fine-tuned model to Hugging Face Hub. As you can see, I have uploaded it in my profile like this, and it's uploaded. Then we will move on to third part, which is reinforcement learning using DPO dataset. So in this, first we'll set up our environment and install the required libraries. For this one, we are installing Torch, Torch Vision, Xformers, Unsloth transformers, and then we'll verify the library imports. We will import all the libraries, and then we'll move on to initial setup and configuration. As you can see, it configures all the required variables. Policy base, max length is 768, subset is 1000, max steps 200, max target is 128. Then we'll move on to loading part and reference model. Then we will load our preference dataset, as we are using here direct preference optimization to make it idle. And then we will move on to pre-processing part. This is the sanity check, and in this one we will also do sanity check. As you can see, it did sanity check, and then we'll move on to DPO configuration and training wiring. So this was the outcome. Then we will train our model. As I have told, we have used 200 steps in here, 4 epochs and 1000 examples. And at last we'll save our output. So this is how we will save our output, and this is like a simple example of it to test it. Then we'll move on to fourth one, which is reinforcement learning with GRPO. And in this we are building a reasoning enhanced model. So as usual, we will start with installing all the required libraries, import it, then authentication of Hugging Face and weight and biases. For this one we are using NVIDIA 800 GPU, and we'll move on to dataset prep. And trigger function for GRPO, and then we will attach LoRa adapters in here. And this is the trainer setup and run. And yeah, in this one we are using 300 steps, 2 epochs and 800 examples. And at last we'll save and export artifacts. And yeah, we'll verify the inference helper as well. And for testing, we'll test it as well. So it will, when you're testing this model, it will generate responses strictly in required XML format, and then produces correct numeric answer, automatically self-corrects if the output is incomplete or incorrect. As you can see, we got the output. And then we'll move on to fifth one, which is continued pre-training. And here basically we are changing the language to Hindi. So first we'll start with installing the required libraries, authentication of Hugging Face. Then we'll continue our pre-training. Our target language here is Hindi. As you can see, we are using Qwen2 model in here. Target language is Hindi. Sequence length is 2048 and 4-bit quantization is true. We'll load our base model. And for this one, I'm using Tesla T4 GPU, and then we'll load and prepare MC4 dataset, which is LNAIC4 dataset. And we'll configure LoRa adapters in this as well. And yeah, the SF training part, supervised fine-tuning trainer, So we will configure it, and then we'll run our continued pre-training. For this one, I'm using 200 steps, one epoch, and 20,000 examples. And then finally saving LoRa adapters and tokenizer, inference sanity check. As you can see, it will generate it in Hindi. So we are using a prompt in Hindi, and we got our answer in Hindi as well. So that is it for this one. Thank you so much for watching.